here's something fun that I made up. It's just two strips of aluminum foil, and I glued them onto a piece of cardboard. You'll notice that if you look closely that there's a lot of sort of bits that are missing on there. There's a reason for that. We'll talk about that in a few minutes. So what I've tried to do is make what I would call an electromagnetic trolley. So what we know is that when we have two magnetic fields that basically come into contact with each other, there's two things that can happen. There can either be an attractive force between those two fields, or there can be a repulsion between those two fields. Okay, so ultimately it's the interaction between those field lines that determines whether or not it's going to be attractive or it's going to be repulsive. So we have some magnets here. These are sometimes called supermagnets. They're neodymium magnets. These ones are a bit beat up. There's a reason why I use the ones that are a bit beat up, and it's because this demonstration is a little bit hard on them. It actually tends to sort of wreck. There's actually a coating on the outside of them, because neodymium is actually not this really shiny material that's on the outside. If you can actually see sort of on the side here where some of them have actually cracked and split off, you'll see it's actually sort of a dull gray color. That's actually the true color of neodymium. So they've actually got a conductive coating on them. Not entirely sure what the coating is, but that coating, once you pass electricity through, especially if there's enough electricity, it can actually sort of wreck that coating on them, in the same way that it actually is wrecking the aluminum foil strips here. So I'm kind of using I've got some nicer ones, but I'm not going to use them because they do get a bit wrecked in this demonstration. So I'm just going to take two off. So here's a pro tip for you. When you have really strong magnets like this, you're not going to be able to pull them apart. You got to slide them with the thumb, like so. The thumb and the finger, and you slide them off like so. So I'll just put the rest of the stack there. So I've got two of these magnets here, and my trolley is going to consist of those two magnets and also an axle. So basically the magnets are going to act as wheels, and I just took a coat hanger and cut it off on either side. There's an enamel coating on the coat hanger, so I sanded that off. Then I basically just filed down the sides to make it so that they were relatively flat, and this is going to be our trolley. So clearly we've got a magnetic field from both of these magnets here. Okay, that's going to be important later on. So in order to get the trolley to move, we're going to need a force. Nothing is going to move unless a force is being exerted on it. So in this case here, we need a force. Well, I know that's going to be the interaction between two magnetic fields. So obviously this is going to be one of the magnetic fields. Together, they're going to produce a relatively strong magnetic field, but quite localized. And where is the second magnetic field going to come from? Remember what a magnetic field is. What produces a magnetic field? Well, ultimately a magnetic field is just a moving electric field. So if I can take charges which have an electric field and I can make them move, that's going to produce a magnetic field. In fact, that is a magnetic field. A magnetic field is just a moving electric field. So the way that we do that, of course, well, how do I make charge move? Well, I connect it to a power supply. So I'm going to, this is kind of the ingenious part of it, is I'm going to connect one terminal to the one strip of aluminum foil, and I'm going to connect the other terminal to the other strip. And when I actually put my trolley on the strips, what's going to happen is we've actually now created a closed circuit. Okay, so if we follow it, remember when we talk about current flow, we don't talk about the flow of electrons, we actually talk about the flow of positive charges. So if I go to the positive terminal, I can see that this is the positive terminal. It's connected to this strip here, okay, which is connected to this magnet, which is conductive, which is connected to the coat hanger, which is also conductive, and then this magnet, and then to this metal strip, and that's connected to the negative terminal. So we get actually a closed circuit here, which means that we're going to get current that's going to flow through these two strips of aluminum foil. That's going to produce the second magnetic field. Okay? So once those two fields interact, if I can create the fields in such a way as to be repulsive, that repulsive force will actually push the trolley along the track. And it's kind of interesting. So I may need to actually reverse the one or two of these magnets to make sure that the fields interact in that way. So we turn the voltage down. You want it to be relatively low to start with, because remember, there's not a lot of resistance in this circuit, because it's really just essentially just metal wires, and everything here is metal, very low resistance, which means that there's going to be a fair bit of current that's going to flow through there. We're going to get some sparking and so on. So let's just have a look at it and see what happens. So I can actually see that really nothing happened. Kind of might be a bit hard to see it on the camera, but this one here moved a little bit. So the fact that this one here moved a little bit, but the trolley as a whole didn't move either direction on the rails, that suggests to me that the polarity of the magnets is not, they're not actually lined up, they're not actually complementing each other, they're actually canceling each other out. So that's a good indication that what I should do is I should actually reverse one of the magnets, and that might actually solve the problem. So I'm going to go ahead and try that, and we'll see if we get a different result. Okay. There we go. So we can see that we are actually getting a repulsive force. So the reason that it went down at the end there was actually due to the gravitational force. It's a bit hard to see here, but this piece of cardboard is actually slanted up this way a little bit. This end of it is actually slightly off the table. And that would sort of explain why it's going so slowly, because the magnetic force basically has to push the trolley uphill. But then as soon as I turned off the power supply, that force was no longer there, so the gravitational force then caused it to come back down, just like it's like an inclined plane, essentially. So it's actually quite hot. Again, there's very little resistance in this. You can actually smell a bit of a smoky smell, because actually this coating on the magnets, it actually will burn off, and things get very, very hot. And so basically the magnets getting very, very hot, sometimes they'll actually stick to the aluminum foil, and that's what's actually caused all this sort of tracking that we saw in there at the very beginning of the video. So what I want to do is I want to go into a bit more detail in terms of, well, what is the force? Why is it going this way? Why is it a repulsive force? Why doesn't the trolley move, down towards the wires instead? So it all has to do with the hand rules. So ultimately, if you look at this piece of foil here, we know that we're going to get current that goes through this piece of foil, this strip here. So just take that off, and maybe I'll just hold this up to the camera so it'll be a bit more clear. So remember that this one was attached to the positive terminal. So that means that basically the current was going this way, then it went across through the trolley, and then it went this way through the negative terminal. So using my hand rules, I know that we're going to get actually a magnetic field produced by both of these strips. So how do I figure out that magnetic field direction? Well, my thumb points in the current direction. My fingers then will indicate the direction of the magnetic field. And so the magnetic field between the two rails is actually going to be towards the camera. Okay, so again, thumb points in the direction of current flow. My fingers then indicate the direction of the field. So in between the two rails, it's actually going to be towards the camera. In this context here, of course, it would be directly upwards, right, the way that we just saw it. Now on the other side, the current's going the other direction, but in between, so it's a bit sort of awkward to do this, but in between, I can see that the magnetic field again is towards the camera, which in this context would be upwards. So those two magnetic fields actually complement each other, and in between the two rails, they're actually both in the upward direction. So now we introduce the trolley. So on the actual trolley itself, the trolley sits on there like that. We're going to have current that basically flows this way through it. There's going to be an external magnetic field because of the rails that, remember, was directed towards the camera. My palm then indicates the direction of the force. Look at that. Just like that. And that's the direction, of course, that it goes. Now, if I were to, let's say, change the magnetic field around by, let's say, reversing these two magnets here, we would expect that the direction of the force would actually be reversed as well. So I've gone ahead and I've reversed the two magnets. And I'll just connect it to the power supply again. So remember, I've reversed the polarity, so I would expect now that the force should be in the other direction. Let's see if that happens. And it does. Okay. So yeah, and it does. Ooh, it's starting to get quite hot here. It's a bit hard to handle actually. Now, so the thing that really has sort of messed with the rails that I've made up is when you turn the voltage quite high and you get quite a bit of sparking. So I'll go maybe to 4 volts. We'll see a bit of, there we go. Yeah. So it's actually gotten so hot that it's actually just burning holes and it's actually sticking to the foil. So it's actually, in a way, the 4 volts doesn't actually go as well as 2 volts, because when you put the 4 volts on, it gets so hot that it actually just sticks to the foil and doesn't really move as well. Now at the very beginning, when I got these 2 strips here, when I first made it, and they were nice and smooth and there was no bits missing here and there, there's no tracking on there, I actually put it to I think 8 volts and it just sort of went quite quickly. But over time, as the coating on the magnets has broken down, as the foil itself is broken down, yeah, it doesn't actually go as well as it did when I first made it.